Okay, folks, so in this section what we're going to look at is something called restrictions on radical expressions. So basically what that means is there are going to be certain values for an expression with a radical, so some kind of algebraic expression. There'll be certain values of a variable that make that expression sort of not work out to anything sensible. So we're going to look at ways to determine what wouldn't be sensible and therefore what would be sensible for a particular type of expression. So we're going to talk about, in order to do that, radical expressions that have some variables in them. So the first thing we want to look at is sort of a bunch of radicals and talk about what's okay and what's not okay. So the first thing we want to talk about here is, what if I have something like the square root of x? So we're looking over in this direction right here. So if I have the square root of x, are there any values of x that would make this sort of explode or turn into a black hole or something? And the fact of the matter is, yes, there are. So what does a square root mean? It means I'm trying to find a number. So for instance, if I have an example like square root of 9, I'm trying to find a number that when I square it, I get 9. So in other words, that number times itself gives you 9. So we know that that would have to be 3. But what if I have to take something like square root of negative 16 for another example? If I have to take square root of negative 16, well, there's no number multiplied by itself that'll give us a negative answer. So I can't take a square root of a negative number. So that's not allowed to happen. So if I have something like square root x, basically that whole thing is undefined whenever x is a negative number. So what we do is we put a restriction on it. We say x is not allowed to be negative. So we're going to say it cannot be a negative. So in other words, what we say is that x has to be a number that's greater than or equal to, because we can take the square root of 0. 0 times 0 is 0. So x has to be a number that's greater than or equal to 0. Now, with a cube root, like cube root x here, it's sort of a different story. For example, if I think about a cube root, let's think of something that's a nice perfect cube like 8. So I know the cube root of 8 would be equal to 2, because 2 times 2 times 2 is 8. What if I had the cube root of negative 8? Well, if I make that negative 2, think about it for a sec. Negative 2 times negative 2 would be positive 2. Multiplying by another negative would make it negative. So I can have a cube root of a negative number. So in this case, there's no value really of x that would make this explode or anything. So we're okay with any value of x here. So sometimes we say x has to be any real number. Okay? So there's no restrictions on this one at all. X can be anything at all. And sort of the key thing to remember is if the root that you're taking is an even root, like a 2 or even a 4 here, then you have to be dealing in positive numbers because you can't take an even root of a negative. But if it's an odd root, you're okay with anything. There is one other exception to this sort of thing, and if I have a square root of an expression where the variable itself is raised to an even power, or if I have an even root where the variable is raised to an even power. Let's think about an example here. Let's say we want to take x equals negative 3. Now we already know for this one over here that would be a no-no, or for this one right here that would be a no-no. But in this case, if I let x equal negative 3, I end up with the square root of negative 3 squared, which would actually be the square root of positive 9, and that would be 3. So that would be okay. So because this square would turn anything we throw in there into a positive, there's no restrictions on that either. So we can say x can be any real number. Okay, so that one's a-okay. Let's think about what we call fractions or rational expressions. They're going to become irrational when we throw those roots into them. But the other no-no that we have sort of mathematically is you should remember you're never allowed to divide by 0. So in this first one, if we have 1 over x, we have to say that x is not allowed to be equal to 0 for that. Okay, because we can't divide by 0. And if x was 0, I'd have 1 divided by 0. For this second one, well, I know I'm not allowed to be equal to 0, but also because x is inside an even root, a square root here, x would also have to be a number that's bigger than or equal to 0. If I put those two together, I have to be positive or 0, but I'm not allowed to be 0. Well, then I have to say I'm strictly greater than 0. So my correct answer there is I have to be positive and I can't be 0 or negative. For 1 over the cube root of x, we're allowed to be negative, but we still can't be 0 because we'd be dividing by 0 for this one. So in this case, x is not allowed to be equal to 0 is the only thing we have to state for a restriction. For the last one, remember this was okay anywhere, but I'm not going to allow x to be 0 here because I'd still end up with a 0 denominator. So the only thing I'd have to restrict for that one is x can't be 0. Okay, so we got lots to be careful about. We're not allowed to divide by 0, and we can't take an even root of a negative. Oftentimes what we'll do is we'll sort of, instead of trying to figure it all out in our head, we'll just sort of get some rules for some algebra. Anything under a root sign that turns out to be negative is trouble. So if we're going to state what we call a restricted domain or some restrictions on that, we just say that the stuff underneath the root sign, which in this case is x minus 3, has to be greater than or equal to 0, because this is a square root. And then to sort of simplify that a bit, or to figure out what that would mean just for x, I just work this like it's an equation, because it's an inequation. Adding 3 to both sides, I find out that x has to be greater than or equal to 3. So those are my restrictions for that one. In this case, the stuff underneath the root sign does have to be positive because it's a square root, but not necessarily strictly positive. Oh, yes, it is strictly positive in this case. Sorry, we're not allowed to be equal to 0 either, because then we'd be dividing by 0. So notice here, I was allowed to say greater than or equal to, but over here, I've got to say strictly greater than. So if I just flick that 5 onto the other side of the inequality, I'd restrict this one by saying x has to be strictly greater than -5. Okay, so a few things to note there. An even root must be taken of a negative number. Sorry, if we take an even root of a negative number, the radical expression turns out to be undefined, so that's no good. Or if we have a 0 denominator, we turn out to be undefined, so that's no good. So to determine how we restrict it not to let one of those two things happen, what we do is we use an inequality. We decide, do we have to be positive, do we have to be strictly positive, or are we allowed to be 0 as well, based on the sort of setup of the thing. Okay, so we'll do some practice questions in the next section. Thanks.